Have you ever pondered the question, what makes up everything we see, touch, taste, and smell? The answer lies in the heart of a tiny particle that builds our universe, the atom. Today, we journey through history to unravel the mystery of this microscopic marvel, its discovery, its structure, and our current understanding of it. The concept of atoms dates back to ancient Greece, around 400 BC. A philosopher named Democritus posited a rather radical idea for his time. He suggested that if you keep cutting a piece of matter, you would eventually reach a point where you could not cut it any further. He called these indivisible particles atomos. However, this idea remained a philosophical concept for centuries without any scientific proof. Fast forward to the 19th century, when the English chemist John Dalton breathed new life into the ancient Greek idea of atoms. Dalton performed experiments with gases, leading him to propose that elements consist of atoms, which combine to form compounds. He also suggested that all atoms of a given element have the same weight. Dalton's atomic theory laid the groundwork for modern chemistry. Then, in the year 1897, J.J. Thomson discovered the electron, a negatively charged particle within the atom. His plum pudding model suggested that these electrons were embedded in a positively charged sphere. But this model didn't hold up for long. Enter Ernest Rutherford in the early 20th century. He found that atoms are mostly empty space, with their mass concentrated in a central nucleus. Rutherford's model showed the atom as a mini solar system, with electrons orbiting the positively charged nucleus, much like planets orbit the sun. However, the puzzle wasn't complete yet. In 1912, Niels Bohr proposed a model where electrons move in fixed orbits around the nucleus. Bohr's model also explained why atoms emit light in fixed wavelengths, a phenomenon that puzzled scientists for years. Fast forward to the 1960s, scientists discovered quarks, the fundamental particles that make up protons and neutrons in the nucleus. This discovery led to the development of the Standard Model of particle physics, which describes the basic building blocks of matter. Today, our understanding of the atom is quite different from Democritus's indivisible particle. We know that atoms are made up of three key particles: protons, neutrons, and electrons. Protons and neutrons reside in the nucleus, while electrons whiz around in a cloud-like formation. Quarks make up protons and neutrons, and there are even tinier particles called leptons, which include electrons. In summary, the understanding of the atom has evolved dramatically over centuries. From Democritus's uncuttable atom to Dalton's elemental atoms, Thomson's plum pudding model, Rutherford's nuclear model, and Bohr's orbital model, each step has brought us closer to our current understanding of the atom's structure. Today, we know that atoms are a bustling metropolis of subatomic particles, and the study of these particles continues to unlock the secrets of our universe. So, next time you marvel at the vastness of the cosmos, remember that it all starts with the tiny, yet complex atom.